Alright, let's carry on with some atomic theory history. Next up was Rutherford, and some of you might recognize his name. He was British. He worked at McGill University in Montreal, so there's a Canadian connection here. He won a Nobel Prize in 1908 for his work with radiation, specifically the gold foil experiment. So what he did is he took a source of alpha radiation inside this lead box with a tiny little hole in it, and so it could only shoot out in one direction. I think he might have also put a little screen with a hole to further make sure that it was only going to travel in straight out here. And he had a piece of thin gold foil, like a piece of aluminum foil here. And when the radiation was shot out, he expected it to bounce back. But what he had here was a fluorescent screen around, so anytime an alpha particle hit the screen, it would glow. And to his surprise, most kept on going straight through when he did this experiment. Sometimes he'd get a bit of deflection at an angle, but most went straight through, and even more rarely he'd get some that would come in and bounce back at a large angle or straight back. And this was a big surprise. Like, this is a solid piece of gold foil. You can't see through it, and yet things were moving straight through it like it wasn't there. So the conclusions that he came to here: alpha radiation, first of all, is positive. It has a charge of +2. And most of the radiation went, like I said, straight through the gold foil. So that meant, the conclusion that he drew was that the atom is mostly empty space. Now, once in a while, some of this radiation deflected slightly, and that meant that there must be something positive in there, because if it was negative or neutral, it wouldn't be deflected away. And then some things deflected at large angles or straight back, and that meant that there's got to be something pretty dense in there, and it's also got to be positive, because if it had any other charge, it might stick to it. And neutral also it might stick to. So he came up with something you might recognize. He came up with the dense nucleus, yes, and outside it were the negative electrons that were spinning around. Okay? And further experiments by him led him to discover the proton. And I forget what it was called. The first. Proton means the first. And he also discovered that it had the same charge as an electron. So if an atom was neutral, it would have the same number of protons as it did electrons. Now, other scientists continue to work away here, and they discovered that all atoms in an element were not identical. And when two atoms of carbon or nitrogen or whatever we want are not identical in mass, that meant that they have a slightly different mass. It means that we use the term isotopes. Yes, a different number of neutrons. Okay, and you realize there must be something else in the nucleus, and they did call them neutrons. The masses weren't working out with just protons, and so that's why they went looking for the neutrons. Now, unfortunately, Rutherford had a few problems. His model did not explain why the nucleus stayed together. If you're going to stick a bunch of positives in the nucleus, why would they all want to hang out together? They want to repel each other. Problem. Also, too, and you don't know this, but when two charged particles move near each other, energy should be given off. But there's no sign of energy being given off as these electrons moved around randomly around the nucleus of the protons. So this was also two strikes against his theory that, well, I wouldn't call them strikes necessarily, but his theory wasn't complete, and it forced other scientists to keep looking for more. And we'll talk about those in the next video.